like Saturn? No, people have actually picked up on what this looks like. Zerg. You see it now? It's from Toy Story. Gotta defeat evil Zerg.
Wait, the three little Martians.
No, the video game guy.
Oh, yeah.
Where the Tyrannosaurus Rex. You gotta beat evil Zerg. And he starts playing the button with his hands. He's like, I can't get it. So, I just thought it was pretty cool. But yeah, this is the kind of stuff we're doing. It's actually the easiest thing of this entire chapter. And I'm not lying to you.
Can we just take like a separate class on this?
No. No, but there will be questions on there. For example, if I look at something very simple like this, what are these two equations made up of? We have x squared plus y squared equals 13, and y equals x plus 1. A circle and a straight line. Isn't that redundant? Aren't all lines straight? It's a circle and a straight line. Well, there you go. Only in 3 dimensions on a sphere. Because when all lines are straight, but lines are curved if they're in the spherical plane. Anyway, how many different ways can a line intersect a circle? It can intersect in 2 spots, and it can intersect at 1 spot. So what we're going to do here is we're going to figure out these intersections of ordered pairs. So if you take a look at what you guys have, you have y equals x plus 1, and you know that x squared plus y squared equals 13. Can't you just substitute in? If y equals x plus 1, can I do x squared plus x plus 1 quantity squared equals 13?
So it'd be 2x squared plus 1 equals 13.
You just killed a puppy.
Oh, I did. I totally did.
You have to foil.
It's like Lenny. Lenny.
No.
Spoiled and your class isn't there yet. My class isn't there yet.
Too soon.
Wow.
Why did you do that?
I'm guessing Lenny killed a puppy.
No.
Oh yeah.
Too soon.
Why do I have to be in the dumb class for humanities? We're not there yet.
Anyway, notice what I did there. I just substituted the x plus 1 into the y. I FOILed out, and now I moved the 13 over because we're going to have to, dun dun dun, factor. Combine your like terms. We get 2x squared plus 2x minus 12 is 0. What is your first rule of factoring? GCF. What's the GCF here? 2. Factor out the 2, and you're left with x squared plus x minus 6 is 0. Let me ask you this. When you are factoring solving for zeros and you factor out a constant, does it have any bearing upon the rest of the problems? No, it doesn't. So at this point here, what I could do is I could divide both sides by 2 to get rid of it, or I could just leave it there and say the heck with it. Because what's 0 divided by 2? 0. Okay? Error. Wrong. So what times what's negative 6? Yeah, together we get 1. So that means my 2 zeros that I get from this factor winds up being at negative 3. X could be negative 3 or positive 2. So that's telling us right now we have an intersection at 2 spots. One of the spots has an ordered pair of negative 3 comma something, and the other one is at 2 comma something. Which means when you go to figure out your ordered pairs now, you'll have a negative 3 and a 2. Well, how are you going to figure out what y is given these 2 equations? Yeah, absolutely. Does it matter which one you choose? Oh, the second one's just easier to work with. Because what is negative 3 plus 1? What is 2 plus 1? So your ordered pairs. And there you go. Again, all we're doing here is using some sort of, I don't want to call it linear combination because these aren't lines always. We're using some combination elimination method to solve these. And you guys have all done this, you've done it multiple different times. What's gonna be different today is that there's gonna be x squared terms and stuff. You have to do a little bit more factoring with it. Okay?
So our goal is just to find the intersection points, so we have to graph it?
Nope, there's no graphing, there's no nothing involved here. The reason that I put this one out, because you can tell right away that one's a circle and a line. Most of these you're not gonna be able to tell what it is. There's no reason to know what they are. I don't care what they are. So let's look at this one. Same basic idea. Do I want to go through the process of completing the square and figuring out what I have here? No. I don't need to. All I need to be able to do here is figure out the easiest way to solve for x's and y's. You could. You could use subtraction. Remember you've done this elimination method by adding, you've done elimination by subtracting, you've done substitution. What were we going to say to do, Paul? Very good. Everybody hear what he said there? Notice you have a 4y squared at the top and a negative 2y squared at the bottom. If I multiply that bottom equation by 2 and I add them together, won't the 4y squareds drop out? That's what we're doing here. We're working within the ideas of stuff that you've done. First equation was x squared, 4y squared minus 4 is 0. Multiply this whole one by 2. I get negative 4y squared plus 2x plus 4 is 0. Which now means I can add these two equations together, which eliminates the y squared. X squared plus 2x is 0. It just so happened to eliminate 4 and the negative 4 as well. And now, again, what's the first rule of factoring? What's the GCF here? X. Factor out the x, you have an x plus 2. Now, what are your two possible solutions for x?
0 and
Very good. You have 0 and negative 2. And again, just like I did a second ago, when I figured out that I'm going to have two possible solutions for x, I write down those two solutions real quick in ordered pairs. 0, negative 2. And I just go ahead and resubstitute into one of the equations to figure out what y can be. Again, does it matter which one I choose? No. We'll use the top one. If I use the top one, can I say that it is 0 plus 4y squared equals 4? So y squared is 1. So what's y? What's the square root of 1? 4. So y can be plus or minus 1. Here's where it gets a little fuzzy. That single value of x gave me two possible answers for y. So that means all I have to do is just write it out twice. 0, 1, 0, negative 1. That's all. You could get a duplicate answer with one of the x values. You could get a duplicate answer with one of the y values. You want to know, can I just write plus or minus 1?
No, I was going to say, are then those both real intersection points on the circle?
Yes, sir. It could be a circle, it could be an ellipse, it could be a hyperbola. I really don't care what it is. All I'm saying is that if it was a circle, at 0 here and here, they're just intersecting each other. That's all it needs, with whatever shape this other curve is. That's all. Okay. But like I said, I really don't care what the shape is. It's that weird, what was it? It's like hitting here and here, and then the other spot's over here. So it might not be that. It could be something like that. And then we have it here. So maybe it isn't these two shapes, but you get the idea. It could be two. It could be this. 1, 2, 3. Then I do the same thing basically with the negative 2. What's negative 2 squared? 4. So that means I have 4 plus 4y squared equals 4. That gives me 4y squared equals 0. So what's y? 0. Again, it's nothing more than some sort of combination method to go ahead and solve things out. Double check to see if you, the biggest mistake people are going to make on these things, when you take a square root over an equal sign, you forget to do plus minus. That's all. Everything else is really straightforward. Okay?
Is there any way that you could plug these into matrices?
No. That was a square term.
Alright.
Matrices are for linear stuff.
Really?
Do this one. So hopefully at this point, if you added these two together, you got 2x squared minus 16x, bless you, plus 30 is 0. And then you got, what's the first rule of factoring? GCF. This 2 has no bearing upon the rest of the problem. What times what's 15? You add together, you get negative 8. Gives you 2 possible solutions for your x values, 3 and 5. So when you start out with your ordered pairs, you'll have a 3 and a 5 for an x, which means you just substitute back in. I'm going to use that second equation because it's a little bit easier to work with. When I use the second equation, I'm going to go ahead and just kind of shortcut it right away and say it's x squared minus 9 is y squared. So what's 3 squared?
9.
What's 9 minus 9?
0.
What's the square root of 0?
0.
Jack, what's 5 squared? What's 25 minus 9? What's the square root of 16? 4. So with the 5 value, you have 2 possible solutions. Forget the plus minus? And I just said that. You're going to forget that. Don't forget that. And that's it.
Is it also plus or minus 0?
No. That's something I would expect out of these guys.
So if you get a strike.
Yeah, it's a stern look. Do those.
That's a lot of numbers.
There's 7 of them. What I have done here is I've chose 7 of them that are relative, that should work out cleanly. There are times where you could get answers and solutions that work with square roots of, really nasty looking numbers. You could have to use quadratic formula, things like that.
Oh, you want to be in it?
No.
You got this.
But in this case, I try to pick out ones that worked out to pseudo-normal looking things. So the worst possible answers you could get are simple fractions, halvesies, quarters, things like that. Nothing like, 17 root 3 over 4. That's just mean. All right? We'll check this tomorrow and we'll start putting everything together again for Friday. Thanks, guys.